Before getting into this topic, it's time to leave the Python interpreter for a while and start reading and writing code using a more advanced text editor. Actually, a text editor with IDE capabilities like syntax highlighting and code completion. By the way, IDE comes from Integrated Development Environment. As I said in the beginning of this course, I prefer Komodo Edit, which I have already installed on this virtual machine. Of course, you can use any other text editor or IDE. To start Komodo in our virtual machine, you should open a root terminal like I did here and go to the following directory: root, Komodo edit, and bin. Let's do an ls here. Here you should run Komodo by typing a dot, a forward slash, and Komodo. Wait for a while. Okay. Notice we get an error here. Seems it has something to do with the graphical user interface of Linux. I should troubleshoot that, but for now Komodo is open and running. One thing to be careful about at this point is to not hit Ctrl and C in this terminal right here, because it will close the Komodo process. So, see, the Komodo is gone. Okay, so keep this in mind. Now let's reopen Komodo. As a side note, sometimes you might also get another error when trying to open Komodo or in fact any other graphical interface application from the Linux terminal. Something like this. No protocol specified, error cannot open display. This has many controversial solutions if you look in the Linux forums, but a simple restart of the virtual machine worked just fine for me. Another solution to this error is to copy the Komodo Edit 8 folder I just showed you into home Debian and then run it from there using the same command, /and Komodo. Anyway, back to programming. In Komodo Edit, to create a new Python file, just go to File, New, and select python.py. The first thing you notice is that Komodo adds the shebang line by default, in case you forget. Now let's see the way Python connects to a router and executes some commands using Telnet. I will open a Python script, a template for Telnet connections using Python, and I will explain it to you line by line, just to skip some typing and save some time. Then I'm going to test it on a router in the GNS3 network we just built. Don't worry, you have this template or code snippet available for download somewhere in the next lectures, along with templates for SSH and SNMP connections. Just because you shouldn't memorize these commands and module methods, you should just understand them, and when it's time to use them, you should have the appropriate resources, like these templates I told you about. So let's go ahead and open the Telnet template. Open File. Let's go to Home, Debian, Working Directory. I made the new directory here called Templates. And let's open Telnet template. Okay. So, having the shebang line already written and the necessary modules imported, we will use a function to wrap the code for the Telnet connection for modularity and code reuse. I called the function openTelnetCon, which takes a single parameter, the IP address to which we want the connection to be established. Okay, so this is it right here. Let's skip the try except block for now. We'll discuss it at the end, after going through the code. So the first thing we do is define the username and the password that we are going to use to log in. So two variables, one holding the username value as a string and the other holding the password. Next, you should specify other parameters for the Telnet connection, like the port, which is 23. That's the default Telnet port anyway. Next, you can configure a connection timeout value in seconds. This is optional but recommended. For this, you create a new variable, connection timeout, with an integer value of, let's say, 5 seconds. The final parameter you can add to this equation is the reading timeout. This is useful when reading the output from the router and expecting to find a string. The reading of the output takes place until that string is found or the timeout expired. Now, the fun part. Before continuing, let me open GNS3 and start router 1, for example. Okay, now it's time to get the router ready for accepting Telnet connections. If you loaded the configuration files from my drive on your routers in GNS3, then you already have the Telnet settings in place. Just in case, I have attached to this lecture a txt file containing the settings you need to make in order to enable Telnet and SSH connectivity on your router. Now back to the virtual machine, let's open a root terminal and check the connectivity to R1, so ping 192.168.2.101. Great, it works. As a side note, sometimes when my PC enters the sleep mode, having the virtual machine and GNS3 open and connected, and then I wake it back up, the ping from the machine to the router fails for some reason. It may be a GNS3 bug or known behavior I'm not aware of. Anyway, the solution to this is to delete the cable connecting the virtual machine and the hub, and then add it again, and it will work, I guarantee it. I thought maybe it will happen to you too, and you should know about it. Okay, now let's open a Telnet session to the router and see what should our Python application expect when connecting to the router. So let's do a Telnet on 192.168.2.101. Let's enter the username and the password, which is Python. And now we are in the router's CLI. That is the router prompt right there. Great. So, summarizing, we opened a Telnet connection to the IP address of the router. Then we were asked for the username, right here, and the password, right here. And in the end, we got the prompt. Okay. Now, back to our application in Komodo Edit. The same things we encountered while telnetting into the router are going to be found by the Python application too. So let's take them step by step from Python's point of view. First, we should open the connection to the router. This is accomplished by creating an object called connection and using an instance of the Telnet class and passing the IP variable right here, which is the address we are going to give as an argument when calling the function down here. Then we have the port number and the connection timeout. After the connection is opened and the channel is established, the router will ask our application for the username. So we should instruct Python that it should read the output from the router until it finds the string username. This is done with the readUntil method, giving the expected string as the first argument. Okay. As soon as our application finds this string, it will use the write method we see here to enter the username we defined earlier, so TEOPY, and a new line character to simulate the enter key. The same thing is done for the password field. Python reads until the password is requested, so until it finds this string right here. Then it sends the value associated with the password variable we defined, and the \n. Good. Next, notice I told Python to sleep for a second. By this, I tried to take into account any delay that the router might generate while verifying the username and password I entered. It's safer to add the sleep function whenever you think a short delay might interfere with your application. Now, let's stop here for a moment and analyze the next line of code. As you can probably guess, I am sending a command to the router. So, terminal length 0. What this command does is it disables the pagination for commands that have a long output, like show running config, for example. So let's try this in the console, so show running config. Notice that at some point we get the more you see here. This is not what we want when capturing output from the router. We want all the output back. So if we type terminal length 0, then the pagination will be disabled. So let's try this one more time. Okay, great. We now have the entire output. That's why it is a good practice to have this command in your code before entering any other commands. So let's get back to the code. Now, as you probably know, you should enter the global configuration mode in order to make configuration changes on the device. So that's what I did with the next line of code. Okay. At this point, I could continue typing in commands as arguments for the right method to have them sent to the router, but that wouldn't be fun, and not very practical either. No one wants to modify the application code each time a new command or set of commands should be sent to the device. That's why we're going to tell Python to pick up the commands we want to enter on the router from a text file having each command written on a separate line. We could just hard-code the file name inside our application, but that wouldn't be fun either, and not very flexible. Instead, we are going to ask the user to enter the file name when he runs the application, using the row input function we talked about in the first lectures. So let's define cmd file up here equals row input of, let's enter a string, enter command file name and extension, colon, space, and close the double quotes. Okay, explicit enough. As you remember from the file section, to read the data from a file, Python has to open it for reading, ensure that the cursor is positioned at the beginning of the file, and then read each line using the readLines method. This returns a list where each element is a line in the file, remember? Good. So we open the file here, selected CMD file, open CMD file for reading, and then we use seek of 0 to start from the very beginning of that file. Before moving on, let's save this file, and also let's create our CMD file. So let's go into Home, Debian, Working Dir, and Templates. Okay, let's create the file here. So touch telnet commands.txt. Okay, let's edit the file and type in a few commands. Let's say some TechX related commands. So vim I for insert. Let's say TechX server host 1.2.3.4 and then let's do a show TechX. Okay, so we just configure the TechX host and then check our configuration. Let's save it. Now I use the for loop to iterate over the list of file lines generated by the readLines method right here, and told Python that for each line in the file, it should go ahead and send that line to the router with a delay of 1 second after each command just to be safe. Pretty intuitive, I think. Now, to avoid file-related errors, always remember to close the files you open. So this is what the next line of code does, using the close method. Now, if you are expecting an output to be returned, especially if you send the show commands to the router, not just configuration commands, then you should use a method that reads that output and stores it in a variable. The Telnet lib module provides several methods, of which readVaryEager is very useful when you want to read as much text as you can from the command output. That's why I use it here, then I print the value stored in the variable. Finally, let's close the Telnet connection. You should always do that if you're done configuring. Now notice that I wrapped our code inside the try except block. This is the try, and here we have the except, just for capturing any I/O error that might occur, like for example entering an invalid file name. You can further improve this to capture other errors too. Finally, at the end of our file, we call the function giving the router's IP address as an argument. So open telnetcon of 192.168.2.101, which is the address of router R1. Now make sure the file is saved, and let's run this application. But first, let's check that there is no TechX configuration on this router. So let's go into the router's console. Let's do a show TechX. Okay, nothing, blank. Now it's time for the big test. Let's go into the folder containing our application. So this folder right here. And let's test our program. So Python telnet template.py. Enter command file name and extension. So we should enter telnet underscore commands.txt. Okay, victory. We didn't get any errors and Python returns what we already expected. Let's also check R1. So let's do a show TechX again. See if our configuration has been applied. Great, the TechX host has been configured. Furthermore, returning to the output in the Linux shell, we see that Python executed the terminal length command. Then it read the file and sent those commands to the router. And finally, printed out what it read using the readVeryEager method. So the whole output of show TechX right here. Also, in the router console, you may see a log message when configuring via Telnet that says configured from console by user on BTY0, and this gives us the IP address from which the configuration came. This is the IP address of our virtual machine, 192.168.2.100. So this is how you can use Python to telnet into a device, send commands, or read command output. Of course, this example could have been made simpler, using just telnet-lib specific methods, but I wanted you to remember and use some other concepts too, like row input, opening and reading files, or try except blocks. Next, we are going to use the Paramiko module to accomplish the same task using SSH.